All right, here we go. First disclaimer is I plan on being back on Thursday, so you are expected to know how to do this. Um, Teach it the same way that I would teach it in person. Uh, you can also go back and look at the examples. I'm going to start with the homework problems. I might refer to a little bit back in the book. And then this first section, uh, no calculator. Okay, really want to try it without a calculator. Because they'll be on the test on the no calculator part. I'm going to do the odds out of the homework and assign you the evens. So here we go. To do number one, to solve it, we are essentially just going to switch forms. So x equals 4 to the 3 halves. Okay. Now, if we had a calculator, we could just type 4 to the 3 halves in, get the answer, and I mean, there are different ways to do it. The way the book does it is they change the base. So once you switch forms back to exponential, you can then say 2 squared to the 3 halves. And a lot of these end up being pretty simple because once you apply your power rule, 2 times 3 halves, is just 3. So this ends up being 2 to the third, which x is 8. Another way I thought about doing it is you could switch this over to radical form, and you could call this the square root, right? Index on the bottom to 4 to the third. I know many of you know what 4 to the third is, and that is 64, and the square root of 64 is 8. So I'm cool with either way, just as long as you're not using your calculator. Number 3, we're going to say x equals, and number 3 is kind of a tough one when I do it. 25 to the 5 halves, and it doesn't matter which way that I do it. It's going to end up being kind of a big number because I have to change this to 5 squared. 5 squared to the 5 over 2 ends up being x to 5 to the 5th, and I have no idea what 5 to the 5th is, and then multiplying 5 times 5 5 times is a pretty big number. I guess it's not impossible to do. It's like 3,000 or something. I can't remember, but if we get one that big, we'll just probably leave it as 5 to the 5th. Go ahead and do number 5, since it's the same type of problem, but I said I was going to work the odds. So switching forms, that is x equals 27 to the 2/3. We could break that down and say x equals 3 to the third to the 2/3. And then going really fast, that's just x equals 3 squared, and so x is 9. If I would have left it, I could have said, I don't guess that's really easy, the cube root of 27 squared. Evidently 27 squared, I don't know. It's still going to be 9, but, there's my answer. All right. All right, for problems 7 through 12, it talks about example 2. If I go back to example 2, it talks about a property. Let me find example 2. I hear my dog walk through the living room or the dining room where I'm working, but it's okay. All right, so example 2 basically doesn't really state anything, but it is a property that if the bases are equal, and it's just like exponential form, when the bases are equal, you can get rid of them and solve. So whenever that happens, we can set them equal and solve. I guess technically, looking at these problems, I may come back and adjust your homework where I said no calculator, but I'm not able to use a calculator on these. Definitely no calculator on 1 through 6, and then some others. But I guess 8 or 7 through 12 you can use your calculator. But essentially, these are pretty easy. I may not only do one of them. I might do 2, I guess. But the bases are equal. we can set them equal, so 2x squared minus 4 equals 2x. That's pretty simple. Now I will remind you that this is two variable, not one variable, and something that is two variable we're going to have to make equal 0 because we can't solve for x, okay? And from here down, I guess we could use a calculator. And our rules are factoring, using the graphing calculator to find the zeros. We're going to get two answers here. Or we could do quadratic formula. I don't think this one's too bad by factoring. Make sure I haven't made a mistake. We can take a 2 out. Okay, and this is going to be, let's see, multiple of negative 2 that adds up to negative 1's got to be negative 2 and positive 1. And so my solutions here are going to be positive 2 and negative 1. I think that's pretty easy. It's going to get a little bit more difficult on the next page, but we've got to move on to the next section. All right. As I am looking back over the notes, you do need to check for extraneous solutions here, and you got to go back to the original. So again, like I said, I was going to make you do all this without a calculator, but 7 through 12 is going to have to be with a calculator. Now, how you check this, you're going to plug 2 in for the left side, all of it just like you see it. Hit enter. Plug 2 into the right side, and 2 should check out. I believe if you were to actually pause the video and practice this, negative 1 will not check out. So that should be pretty good there. Now the next section, essentially 13 through 24, is definitely no calculator again. And before I do it, I need to reference some properties. They're in different, let's see, they should all be in the same place. So you're going to want to look over this section. It should be very familiar to kind of what like exponent rules, but they are logarithmic rules. So we have the product property, quotient property, and power property. And you're definitely going to want to look over them. They should be pretty basic, right? And they kind of fall along with exponent rules. So, addition is multiplication, division is subtraction, and we have our power to multiply. So when you see me do this math, I'm essentially going to be using these properties. Now, this is more like how we would do these, or I don't guess even we, because this would be too old for me, but how they would get approximations without a calculator. Again, if you put log 430 in the calculator, it's going to give you a decimal approximation. But what they're wanting you to use is other decimal approximations to get an answer, and then you have to use the properties to get it to this level. So let me see if I can make this make sense, okay? So I could say log, if I'm doing number 13, log base 4, 30 is, let me think of something to use here. I could say it is log base 4, 5 plus log base 4, 6, okay? Now, I have a decimal approximation for 5, but I don't for 6. But if you look at the other two, I could write 6 as 2 plus 3. Okay, so I'll rewrite that one. So I still have log base 4, 5 plus log base 4, 2 plus log base 4, 3. Okay? And that essentially is equivalent to log base 430. Now, once I have them with the approximations that they've given me, I can write those in. So this is really 1.1610 plus, what's this one, 0.5 plus 0.7925. Add all those decimals up, I should get the answer. Also, if I want to check my answer by using my calculator, if I add all these decimals up, it should be really close to a log base 430. Alright, if I bump over and look at 15, they have kind of written a number as division, and so when I see division, I should be thinking subtraction. I should really kind of see they break that up as log 4, 2, minus log 4, 3. Okay? And then I can use the decimal approximations they gave me. This is 0.5 minus 0.7925. Okay? And so subtract that. That's going to be what? Negative decimal. Think about that for a minute. Of course, you can write this out. Be a good review for decimal subtraction. Again, you do not want to be using a calculator. But you know, you don't have to be perfect on here, but this is negative 0.2925, okay? And I'm pretty sure if you would type this in, I left my calculator at home, sorry, at school, but if you type this in, you should get that, okay? Number 17, it's going to be, and it really could work this one two ways, but it's going to be, we could rewrite it as log 4, 3 plus log 4, 3. And this is basically 0.7925 plus 0.7925. Now, if you have forgotten how to do decimal addition, I'm not going to take the time to teach that to you. You can look it up, but you know, you can stack them if you need to and kind of add them up. You know, we can also approximate this. You know, it's going to be, what, a little over 1.5 and get that answer, but you can practice that. Another way to have done 17, if you wanted to use, instead of your product rule, we could use our power rule, and we could have written it as log 4, 3 squared. And if you want to go back and review that rule, it is then 2 times log base 4, 3, and so 2 times 0.7925. Same answer, but you're times them by 2 instead of adding it twice. Just a different way to do it. Skipping down to 19 through 24, it's the same skills. They're just giving you different approximations that I'm going to use. So when I see, you know, log 225, it's basically going to work the same as log 49. I could say, you know, log 25 plus log 25. And so I'm adding 2.3219 twice, or again, what I just showed you earlier, you could do log base 25 squared and do 2 times log 25. So 2 times 2.3219. Answer is going to be 4 something. Just kind of trying to skip this up, kind of move faster, get this done. Number 21, I'm just going to do it one way this time. Looks like a lot of these must be working out like that. They must be wanting you to use your power property here, because you know 125 is, you know, I just see it as 5 to the third, so 3 times log 25 and log 25. So this one's going to be 3 times 2.3219. Skipping to 23 is going to be log. You know, I originally was thinking 9 squared, but you know, they did not give me a log base 2, 9. They gave me a log base 2, 3. So instead of 9 squared, I'm going to want to change that to 3 to the 4th. And so this is going to be 4 times log base 2, 3. So 4 times 1.5850. Whatever that is the answer. So once you get it down to the decimals, you should figure out how to do it. Now, switching over to the other page, I'm going to pause here for a second. Now, bumping over to the next page, page 408, and working through those. They're wanting you to use your like base property here with your product quotient or power property, okay? And so just to go through these real quick, essentially when I see that minus, I'm going to write it as a division. Now I will say, if we're using our like base property, if I go back and look at example 2, before we can get rid of the logs, we basically, like if I'm looking at number 27, I need to have log 3 something equals log 3 something. I have 3 log 3's, so I'm going to use my property to simplify it first. So I'm going to say log, see where I can get this, and hopefully you can see it all. Log 3, 56, divided by n, because minus is division, equals log 3, 7. Now that I've used my quotient property and have my bases equal, so just log 3 something equals log 3 something, I can then get rid of those, and 56 divided by n equals 7. I hope you can just kind of, see the answer here. The answer for 27 is 8. When I skip down and start 29, I've got a 5 out front, so to get that to be like base equals like base, I'm going to use my power property first. And so bring the 5 into the power and say log base 2x to the 5th power equals log base 2, 32. And then that is just going to be x to the 5th equals 32. And again, we can 5th root here, but x is going to be 2. Okay. 31, we see the plus, so we're going to make that a power property. And once you kind of see it, once you get the hang of this, I think it's easy. I don't know, what kind of mood y'all are going to be in. I'm going to use my product property to write it with 1 log 2, and now I'm going to have log 2, 8. Now that they're equal, I can get rid of it, so x parentheses x plus 2 equals 8. This is going to, well, it's not really a quadratic. It is, but it's one variable. No, this is going to be 2 variable. So we're going to have to bring the 8 over and, either factor, quadratic formula, whatever you can do to get the answer. So I believe this factors, let me look at the answer sheet. I don't have my calculator. It does factor, it looks like. If it doesn't, you can do quadratic formula. I will say, just like we did on the other example, we're going to get 2 answers here. Make sure this does factor, I guess, before I, let's see, this should be x plus 4, and x minus 2 works, right? Yeah, so negative 4 and 2. Check these answers. Go back to the very original, check them. Just looking at the answer in the back of the book, again, I don't have my calculator, but it's just showing 2 as the answer, so evidently negative 4 does not check out. And again, once you kind of get it, 33 is already set up to do, it's just basically already set up to solve. So we can lop off the bases, solve for x. I hope you could do this one. Times by 4, square root, what is that answer? 10, okay? And then the next one, same thing. Yeah, it's just going to be a quadratic, right? So 3x squared minus 5x equals 2. Bring the 2 over, factor, quadratic formula, whatever you got to do. Okay, so that is the lesson. I'm going to type up in Canvas which ones I don't want you to use a calculator and which ones are optional. Again, if it says no calculator, you want to make sure you are not using your calculator. All right. I am planning to be back on Thursday. We can take questions and go from there. If I'm not there on Thursday, I'll send you another video, and hopefully this makes sense. I'll see you all as soon as I can get back.